Okay. So, the previous class we started with retiming, and quickly what we did is this. We said retiming is a method by which you can change the delays of the various edges in a given data flow graph, maintaining equivalence. That is, the new DFG will be doing the same job at every node as the original DFG was doing, okay. But this gives a formula to change, and that is retiming. And there I said that every sector of DFG, if you pick up, it will be of this type. There will be a node U from which an edge may come up and go to another node, and DFG is nothing but repetition of this. From this node an edge goes to another node, from that node an edge goes to another node, so on and so forth, okay, with or without delay. So, I just take one such sector, and whatever I say, that will be applicable to all other sectors like node, edge node, that kind of sectors, okay. Same thing. We said that for retiming, you choose some integer values, could be positive, could be 0, could be negative, for each node, one for U, one for V, one for another node, and so on and so. Each integer value is called the retiming value of that particular node, okay. I denote it by this, like for node U, R of U, R stands for retiming, R of U, it is an integer plus, minus or 0 which you chose and assigned to U, it is called the retiming value of node U. Similarly, R of V, okay, retiming value of V could be positive, negative or 0, you assign to V, it is the retiming value of V, so on and so forth. There is no restriction as such on your choice, but there is some restriction that will come now. The retiming theorem says that if the edge had W number of delays, W can be 0, 1, 2, 3, dot dot dot, then after retiming you can change it to new value of delay WR, R for retiming, where WR is original W plus the retiming value you chose for the destination node, destination in terms of the arrow, that is R of capital V, minus retiming value of the source node. Source means in terms of this edge, because it is coming from this, so R of U. And this is the new value, and this you do for every edge. So, new DFG will be equivalent to this, that is, it will generate the same sequence at every node which it was doing earlier, but it will be delayed by the retiming value number of cycles for that node. Okay. And there is one point of caution, that since there is a minus sign, you must make sure the whole thing does not turn out to be negative, because negative number of delay has no meaning. This is very important, because suppose you have a loop, then I said that in the forward path, suppose you have a W1 amount of delay, for reverse path W2 amount of delay. So, W1 will become W1 plus R of V minus R of U after retiming this edge, and after retiming this edge it will become W2 plus R of U, because this is the destination now, minus R of V. So, if you want to make R of V positive, very high valued positive number, R of U 0 or negative number, so that this is positive and does not turn out to be negative, here it will have a reverse effect, because here R of U has positive sign, R of V has negative sign, so it will turn out to be negative. So, you have to balance between the two. So, basically for every edge you get one such inequality. The set of inequalities is called the feasibility inequality. Whatever weights satisfy those inequalities, that will be acceptable. You can choose those weights, that is those retiming values, and retime. Okay. If you are given a set of inequalities, suppose 100 such inequalities, because there are 100 edges, you cannot solve them, and solution space may exist, may not exist. If it does not exist, then no retiming possible. If it exists, you can give it to a computer package, it will generate you a solution space. You can pick up any choice of retiming values for the nodes from that space, and that will be fine. Okay. Now, where from does it come? That is the question. That comes from retiming theorem. So, I will give a general statement of the retiming theorem, which I was doing last time, and then the proof can be omitted, but I will give a proof, because proof does not require any higher mathematics, just mathematical logic. Okay. You can skip it or you can follow it. Next thing that I did last time, I said that suppose we consider a DFG of capital N number of nodes. So, node 1, node 2 up to node capital N, but the ith node, it is the Vi, and that produces a sequence, output sequence Vin. So, if you focus on that particular node, and I could be 1, 2, 3, anyone. So, a general ith node, say structure could be like this. This is a ith node, it is producing an output Vin, and other nodes are shown separately here. It may depend on other nodes like node 1 producing V1n, it may go there if there is a connection, it may not go there if there is no connection. I make a provision of a connection with a delay AI1, I from here, 1 from here, AI1 number of delay. If AI1 is 0, 0 delay. If AI1 is 1, 1 delay. If AI1 is infinity, that means infinite delay, which means no connection, because if it is infinite delay, this signal can never reach here. So, that takes care of no connection business also. Then jth node Vjn is the output, it is to be delayed by some number which is dependent on I and j. So, Aij nth node Aind. Okay. So, I am making a very general case where all other nodes connect with this with the respective delays Ai1, Aij, Ain. Some of them could be infinity also, which means no connection. This can depend on its own output. So, output may have a feedback that must have a delay Aiid, and Aii must be positive, because if it is 0 delay, not positive but 0 delay, that means current output to calculate you need the same current output at the input, which is not possible. But if it is at least 1 delay or 2 delay or 3 delay, that means from past output I am working on the current output, which is fine. It may depend on an external signal source S, which produces a signal Xn. I am taking one signal source, there can be multiple signal sources also, that can be easily generalized. It is generating Xn. There may be a path here with some delay or may not be a path here. So, I keep a provision of a path or edge, okay, with Bi number of delay. I do not need two subscripts here, because this is a universal source. So, it does not need a subscript. That is why Bi, the I comes from where it is going, Bi number of delay. If Bi is infinity, no connection, that is signal source does not connect to this ith node directly, okay, or Bi can be 0, 1, 2 as before. Then what does this node do? It takes all the incoming information and does something, okay, and produces an output. What it does, there is a computation load, whatever you have done inside, that you know very well. So, I denote it by a function f dedicated to ith node, fi. It is a function of all the incoming components. So, here the incoming components is V1 n minus so much of delay, n minus ai1 dot 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 Vj n minus aij dot 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 V capital N small n minus ain dot dot dot. You can take away this Vi n minus aii and input x n minus bi. This is what it is producing, and that is done not only at ith node, it could be node 1, so it is V1n, it could be node 2, that is V2n dot dot dot. This describes the DFG, okay, general structure of the DFG. Now, I retain the same structure, but I change the delay values by a retiming formula, as I already discussed. That is, I dedicate some retiming values to all the nodes. What I do for the source node, that I do separately, I will come later. Forget about source node for the time being. All the internal nodes, I give one retiming value R of 1 here, I assign one retiming value R of j here, R of I here, R of capital N, so on and so forth. And using that formula, I change the delay values, okay, by that formula. So, I get another structure. So, that will not generate Vin as such, because the structure has changed, my delay values have changed. So, outputs may be Uin, U1n, Ujn, U capital N, all that. And then I will show an equivalence between Uin and Vin. So, after the retiming, the new structure will be like this. Look at the arrow is heading here. So, that is why this is the destination. So, R of I minus the source R of 1. This is producing U1n, no longer V1n, U1n, because new structure has come up. So, I cannot assume the same input. This is node I dot 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 jth. I am dropping that letter capital D from now on. D just indicates delay. So, this is the integer that many times delay, and I make sure that this is not negative. None of the fellows, even though there is a negative sign, it is not negative, that I have taken care suppose by my choice of the retiming values. So, it will be generating UJN, delay is original Aij plus R of I, this is ith, minus R of j original AIN plus RI minus RG, destination retiming value minus source retiming value. Okay. This is the output, which is not VIN, it is UIN. Okay. The feedback path I had original AII, then it should be AII plus the retiming value of the destination node, in this case destination is ith. So, AII plus R of I minus retiming value of the source, which is again ith node. So, minus Ri. So, AII plus R of I minus R of I. So, it remains AII only, remains unchanged. This is source, it is generating the same Xn. Here I say something new. Originally I had Bi. When it comes to source node, we assume the source node has retiming value 0. That is, the Bi should be just Bi plus R of I, as though it is Bi plus R of I minus 0, as though the source node, signal source node has retiming value 0. Bi should be changed to Bi plus Ri. This is for the ith case. So, I can be 1 here to here, I can be 2 here, here, like that. So, this is after retiming, this is before retiming, and my claim is they are equivalent in the sense that UIN and VIN, they will be identical, just separated in time scale by a known delay, and known delay is nothing but the retiming value of this node, which you chose and therefore you know and therefore known. That is, we will have claim is UI n, this is a delayed version of this. Okay, this will be VIN minus the retiming value here. UIN is nothing but original VIN minus some delay, and delay is nothing but the retiming value of this node AI1. That is VIN minus AI1. AI1 is the, sorry, I am sorry, this is not the thing, minus R of I. Okay. That is UIN at nth index is nothing but the same VIN, but delayed by RI, or equivalently UI n, if you take RI on this side, n plus RI, this will be your VIN. Okay. That is UIN is an advanced version of this. Is UIN is a delayed version of this, or VIN is an advanced version of UIN. Just if UIN, if you go further up, then VIN. It's the same thing. It is VIN minus something is UIN. So, VIN is n plus the same thing. Okay, I think minus are on that side. This is the claim. So, they are equivalent. One is the delayed version of the other, but delay is known to us because that is retiming value of your choice, and that is the reason they are equivalent. And this is true of all the nodes, so they are equivalent. We have to just prove it. Okay, proving is required because I don't want to just give some theorem and then without leave there without proof, because I mean the person who is attending it, he must know where it comes from. If you don't like, you can skip the proof also, but it will take some time, maybe 40 minutes or so. So, I will just carry out the proof, but the proof does not require any advanced mathematics, it just requires basic mathematical logic and mathematical induction. Okay, induction. Proof by induction. Okay, what we do in induction? We have always done induction in our school. Suppose you are proving something like say binomial theorem, say a plus b whole to the power n. We have all proved, done this proof, n c1 a to the power n minus 1 b and dot 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 finally b to the power n. There is a formula, binomial theorem. We have proved it. If we say prove it by induction, what we do is this: we assume that this is true. We assume that this is true for n up to some integer p. Then we prove true for n equal to p plus 1 also. So, if it is true for any n equal to p, then we show it is true for p plus 1. If it is therefore by the same logic, if it is true for p plus 1 here, it is true for p plus 2. If it is true for p plus 2, it is true for p plus 3 by the same logic. But there is an assumption which is called induction hypothesis, okay, that I am assuming it to be true for n up to some p. So, I should at least demonstrate one case where it is, at least one case where it is true, that I have to do directly. So, maybe you can take p equal to 1 or 0 or p equal to 2 whatever and show that left hand side equal to right hand side directly. If that is true, then for p equal to 1 here, it will be by this logic, it will be valid for p equal to 2. Again for p equal to 2, if it is true, it will be valid for p equal to 3 by this logic, and it will go on. This is called proof by induction. That is, assume this to be true for n up to some index and then prove it is true for p plus 1 also, and then validate that assumption by working out a direct case that for p equal to certain value, this is left hand side equal to right hand side. Same thing we will assume here. What we have to do, as I told you, we have to prove that for every ith node n plus r I is equal to V I n, okay, for every ith node. So, we assume by prove it by induction. So, assume this to be true for n less than equal to some index n not, or less than, maybe less than 1 minute. Up to index some n naught minus 1. This is true for n up to n naught minus 1. That is, if you put n equal to n naught minus 1 here, here also it is true. If you put n equal to n naught minus 2 here, here also it is true, and like that. Then we will show that it is true for n equal to n naught also. Okay, n equal to n naught also. This is by induction. And then one case I will show directly to validate this assumption, that at least for one n naught this is true. That n naught for n naught minus 1, left hand side is right hand side. If that is valid, this will continue. by this recursion. Okay. Now, before I do that, there is one property I want to show. That is, if you go to the previous page, look at any of these two, say here. Suppose this delay is 0 or some of the delays are 0. Then it might appear that VIN here will depend on say V1N only. Suppose AI1 is 0. So, it will depend on V1N only. That is, it will depend on the current cycle, NS cycle output of 1. Or if it is 0, it will depend on the current cycle output of J, that is Vjn. It will appear because this fellow will be 0, this fellow will be 0, so on and so forth. Okay. AI1 will be 0, Aij will be 0, so on and so forth. But we will show that it will actually depend not on the current cycle of V1n or Vj, node 1 that is V1n or node j that is Vjn and so and so. It will actually depend on their past values. This Vin will depend on the node outputs of previous cycles only, not on current cycles, even if some delay is apparently 0. It will not depend on the current cycle, it will eventually depend on the past values of node 1, node j, node n, not in the current value. That is what I will show. That it will effectively depend on V1n minus some value, Vjn minus some value, like that. Even if AI1 is 0, Aij is 0, that is apparently they are 0 delay. Okay, but it will effectively depend on their past values only. That is very important for this. So, that is what I will show. Take example as an example of that case, and so we say n equal to suppose 3. Okay, n equal to 3. So, I have got 3 nodes, say V1n, which may be F1, V1n minus AI1, A11, sorry, I is 1 here. Okay, this is not I. A11, let me make it clearer here. Then V2 n minus A12, but suppose A12 is 0. Okay. If it is A12 is positive, then V1n depends on V2n minus some value, that is the past output of node 2, which is fine, which is what I was trying to say, it will. But in case the delay is 0, A12 suppose is 0, that is the delay from node 2 to node 1 suppose 0. Apparently, it will be like this, as though V1n is a function of V2n, same cycle. Okay. But A11 is a self loop, that I told you AII, that is the feedback of the node I from output to its own input, that cannot never be 0, that has to be positive. That means this fellow has to be strictly positive. Then I can say V3n. In general, it is n minus a delay is A13. Okay. Because destination is 1, source is node 3, so A13. A13, if it is positive, I am done, because V1n is a function of past value of V3n, V3n minus 1 or 2 or 3, whatever. Okay. But if it is a function of the current index n, even then I will show the V1n actually will not be a function of V3n, eventually it will be a function of V3n minus some positive number, there is some past output of node 3. Okay. And then this 3 and input xn minus B1. B1 can be 0 or positive, it does not matter, I am not bothered. If that be, now let us consider V2n. F2 V1 n minus A, now destination is 2, source is 1, so it will be 2 1. Okay. A21, it has to be positive, because here V2n, here V1n depended on V2n, same cycle. And if V2n depends on V1n, that is if A21 is 0, that will mean V1n is a function of V2n, V2n is a function of V1n, which means V1n is a function of V1n, which as I told you is not possible, absurd. That is current cycle node output depending on the same node output. Okay, you cannot do that, that is absurd. You see V1n, if I took the function of V2n, I did not put any delay here. V1n as a case I took as a function of V2n. Then if V2n is when I write as a function of V1, the delay must be positive, cannot be 0. Because if it is 0, if A21 is 0, then eventually it means V1n is a function of V2n, V2n is a function of V1n, which means V1n is a function of V1n, which is impossible. V1n is a function of V1, so you can never calculate V1n. Therefore, this is strictly positive. Then V2 is a self loop n minus A22. So, A22 must be greater than 0, as I told you, every Ai greater than 0. Then V3, again here V2n is a function of V3 n minus, ideally it should be A23, 2 is the destination, 3 is the source, A23. In this case A23 can be positive, can be 0. If it is positive, I am done, because then V2n will depend on past output of node 3. But let me not take up that case, let me take the case where it is actually n only, no delay. Okay. And then x n minus some delay V2, which I do not care whether it is positive or 0. And last one V3n, F3, this is V1, again V3n, n minus, now we will have A31, A31 must be greater than 0, because here V1n was a function of V3n, no delay. Then if V3n also is a function of V1n, no delay, then by the same logic V1n is a function of V1n, which is not possible. So, if it was a function of V3n only, no delay, then V3n must depend on past value of V1, that is V1 n minus some delay, that is A31 positive. Then V2 n minus A32, again this must be positive here, simply because V2n here was a function of V3n, no delay. So, V3n when it is a function of V2n, there must be a delay, otherwise V2n will be a function of V3n, V3n function of V2n, which means V2n will be a function of V2n itself, which is not possible. So, it is positive. Then I have got the self loop n minus A33 positive, and then AII, self loop delay is always positive, I have tell again n minus B3. Now, I go back, look at V1n, I have got first term V1 n minus A11, which is a positive term, which is strictly delayed term, n minus some positive. So, the whole thing is strictly delayed. V2 n minus nothing, n. The moment I find 0 delay, V2n, then I replace by this f of 2, whatever it is, I bring in here. So, it is a function within a function. Within that function, I have got a strictly delayed term, but no delayed term. The moment I find a no delayed term, V3n, there I again bring in the corresponding function. So, this f3 comes up there. So, it is a function within function within function, but there all the terms are strictly delayed. Then I go to V2n, V2n again I replace, the moment it is non-delayed, I replace by this function again, these two are strictly delayed term, again V3n I replace by this, the third one expression, there all the terms are strictly delayed, so on and so forth. So, eventually it will be a nested function, function within a function within a function kind of thing, but all the terms as you can see will be strictly delayed, that is with n whatever will come, that will not be 0, that will be positive. So, this is very important, that every V1n, V2n, V3n are eventually function of the past values of V1n, V2n, V3n, even if the corresponding delays in the circuit in the DFG are shown to be 0, but that means nothing. Effectively, each of the node output is dependent only their past values. Okay. That is all for this half. Using this, I will prove the retiming theorem in the next half. Thank you.